and I'm looking forward to this exchange.
Pete?
Good evening, everyone. My name is Pete Riley, and I'm the Deputy Project Director for VDOT for this particular project. And as Louis said, we're both excited about this presentation this evening.
Great. So we'll look forward to taking your questions in a moment as you type those in. And as we get started, I'll go ahead and ask Louis some questions about the TBM. Louis, you mentioned a few things about its dimensions, its length relative to a football field, but can you tell us a little bit more about how much does the machine weigh? Do you know its horsepower or how much electricity it needs to run this big machine?
Yes, Martha, this is quite the behemoth. The machine is 46 foot in diameter, and that's the size of the tunnel that we're digging. It is 430 feet long when fully assembled, with the cutter head, its shield behind, and all the what we call the trailing gear, or the gantries, that house all of the electrical, mechanical equipment, control systems, cafeteria actually, TBM operators console with all of the various screens and commands and control. It weighs 4,700 tons, fully dressed, and is powered by by electric motors, 12,000 horsepower in all, and requires a substation when you take all the equipment as well as the surface equipment to treat the material as it comes out, all that's electrically powered, a 12 megawatt substation that is fed from a duct bank coming in from the Norfolk area.
That is huge, and we'll look forward to seeing that arrive on site. One of the things Steve Myers mentioned a moment ago was the TBM naming contest, and I wanted to provide a little bit of a postscript to that. Many of the school children in this area participated and submitted some great ideas, and so we're looking at next month, later toward the end of next month, being able to share the results of that and provide the name of the machine. Can you say a little bit, Louis, about how long it'll take to assemble this machine, and how many feet can the machine dig every day?
Well, the assembly of the machines, first of all, the machine is being manufactured in Germany and will be shipped to the East Coast of the United States sometime toward, well, late summer into the fall. It arrives in, of course, in pieces, hundreds of pieces that need to be assembled. And so the heavier components, which are the cutter head, the shield, the erector, and a few other major components, will arrive by barge to South Island from the port where it's going to be delivered here, transferred to a barge, and then barge to South Island, where we are currently getting organized to build a wharf to accept that barge. So we will have an 800-ton crane that will lift those components off the barge and put them on an assembly pad that is next to the shaft, the assembly shaft. And then all the other components, which are dozens and dozens of containers and other shipments, will be trucked to the island sequentially. It's a very well choreographed delivery because of the limited footprint that we have on the island. And so every piece has to go to a specific spot to be taken in a specific order. And it takes about, all told, about 4 months to assemble this machine down at the bottom of the shaft. And to then proceed with the testing and commissioning, because of course we have an enormous amount of wiring to be installed for all the electrical feeds to the motors, to the pumps, et cetera, et cetera. So, and when I say 4 months, we're talking pretty much 6 days a week, 24 hours a day to get this done.
That is a huge undertaking indeed.
And then for your second question, excuse me, for the rate of progression of the mining, on average, and I say on average, the TBM will move approximately, 30 to 35 foot per day, and that's a complete finished tunnel that we leave behind. So as it progresses, as you've seen in the video and the presentation, we leave behind a finished tunnel in terms of the lining, and then of course we have all the internal structures to build. So the range of progression of the TBM is a function of the ground conditions and a number of variables. It can go as high as 60 feet perhaps in a day, 70 feet depending on conditions. But on average, we're looking at 30 to 35 foot per day.
Can you give us an estimate of how much total spoil or excavated material is coming out of the machine, and where does it all go?
Well, right now, the total volume is in excess of 1.5 million cubic yards of spoil, and this is all fine sands, some clays, a bit coarser sands. When it is excavated, it is pumped to the surface through a 22-inch steel line that's pressurized, of course, up to the surface to a treatment plant where we separate the water from the sand. We then process the sand to compact it to some extent, and then after that, part of the volume will be loaded onto barges to be sent to a landfill, and then part of the volume will be trucked at night to be sent to the same landfill. But just in view of the quantity of spoils that we have to remove, we have to do this 24 hours a day in order to maintain the progression of the machine.
Thank you. Now, in order to meet the project schedule, one of the questions we have is, since there are 2 tunnels that are being drilled, are there 2 TBMs, or will one TBM drill them both?
No, the same TBM will drill both. We will assemble on South Island and proceed to drive the first tube towards the North Island. That'll take approximately 1 year. And then when we exit in that shaft, then we have a big operation to perform, which is to turn around that TBM. So the TBM plus the 5 gantries have to be sequentially removed from the first tube, then turned around, and then we start up again. And so the turnaround is about a 4 months process, and then the second tube will take just short of 1 year. So overall, we're looking at a bit over 2 years from start to finish to have these 2 tunnels driven. And after that, of course, when it's back to South Island, we have to disassemble it, which is about 2 months, and then to remove it from site.
Thank you. And that clarifies one question that comes up. So the TBM will be removed, or I know in some projects it's buried and left in place. What will be the outcome here?
Well, this particular one comes out, and typically on machines like this, the steel component, the big heavy steel shield, and other big steel components are set in a field somewhere for potential reuse. But these big diameter machines are so project specific, they typically are not used again. However, all of the electrical, mechanical, and control components can be recycled into either another used machine that's being refurbished, or indeed into a new machine, or to be delivered as spare parts for another project of similar size that can accept them. And so, and typically that's done through what's called a buyback deal with the manufacturer, who then will, come in and get these components and bring it back to his plant for reuse.
Thank you. We also have a question about to what extent the plans and specs for the tunnel will be posted or made available to the public.
Peter, I think I'll field that one to you.
All right, thanks, Louis. I know the tunnels are actually part of our critical infrastructure, so the detailed plans and specifications for the tunnels themselves will not be publicly available or published anywhere specifically with a specific detail about what's actually included in the plans. That's to the best of my knowledge, yes.
Certainly. And then as far as other information being available to the public, will there be organizational information on HRCP's decision maker and who its primary subcontractors, other partners? Will that be available for the public?
Well, for our part at our HRCP, there is a newsletter. I think the project has its newsletter, and so there's certainly interesting information to be gleaned from those venues. Peter, I don't know if you want to add to that.
Right. Yeah, absolutely, Louis. VDOT actually does also have a newsletter in which we ship out monthly to anybody who's on our distribution list, and it's very easy to do that. Just go to our website and register. We also do a monthly magazine, which has a little bit more detail about what's going on in the project and some of the features or the current operation. So, and the website itself has updated information.
Super. And one question relative to the existing tunnels. If we're going to have 8 lanes across the water at the end of the day, will the existing tunnels be eastbound or westbound, or how will that be arranged?
So the existing tunnels will ferry traffic westbound, whereas the 2 new tunnels will ferry traffic eastbound.
Will there be upgrades to the existing tunnels as part of the project?
Yeah, there'll be some upgrade to be made. I don't fortunately have all the details with me this evening, as this work is some years down the line.
Certainly, and I'm sure we'll share that using the outreach processes that you both mentioned a moment ago. Another question about the TBM is, especially as the tunnel gets longer and longer, how do the workers get into the TBM to get to work?
Well, actually, we have shuttle buses. Given the size of this tunnel, it easily accommodates minivans that can ferry, I think the ones we're procuring is probably 50 to 20 people at a time, right to the heading, right to the machine. That's
great. One of the luxuries we have is another tunnel project very close by. We know that the Chesapeake Bay Bridge Tunnel at Thimble Shoal is being expanded right now. And are there parallels with that project, or lessons or things that can be learned in parallel and used on this project?
I believe so. I don't know much about that project, but yeah, it's a similar nature, in certainly similar ground conditions, I believe, because it's not too far away. Certainly synergies in terms of technical expertise, craft labor, as different phases of the project evolve, that can be transferred. Indeed, I think also on the environmental permitting side and different aspects, I think overall, given the specific nature of these tunneling projects, I think many of the agencies and other stakeholders have grown to understand, the type of work that this is and the requirements.
Thank you. And that's also a good point to highlight is there's relatively few roadway tunnels and bored roadway tunnels in the U.S. And there was one in Seattle, one in Miami, and Virginia is the first to have 2 bored roadway tunnels in the same state, let alone happening at the same time. So that's something we're certainly proud of and excited about, to be able to share those lessons back and forth as we both proceed. We have a question about, will there be a walkway through the tunnel? And if so, will people be able to walk or bike through it?
No, this is strictly vehicular tunnels. There will be an emergency egress corridor in each of the tunnels, but that's in case of an emergency. So by no means to be used for the casual pedestrian or biker.
Certainly. Also a question, you had mentioned a little while ago in your presentation that this was going to be a bored tunnel and not an immersed tube. All the other existing tunnels in Hampton Roads were built by this immersed tube method. Can you share a little bit about why we're using the bored tunnel method for this project?
From what I know, and I was not involved at the time, but I was involved in other such projects in the bidding phase. It's really the technology have made this methodology just more cost efficient and for the government, for Virginia DOT. As in other cases, but this technology is becoming more and more competitive as it enables us to dig through different soil types. Whereas 60 years ago, when most of the big immersed tube tunnels were designed and built, the technology just did not exist. It was not an option.
Certainly. Yes, Pete.
Just a little bit to add on to that, Louis. That's all excellent and correct. I guess one other thing about Hampton Roads being such an active port, the use of this bored tunnel machine actually reduces the impact on the navigation channel, which allows the commerce to continue and the Navy operations to continue, because we won't be impacting those as that TBM moves underneath the channel. It's a very, very big thing here.
That's excellent. Excellent point.
And you touched on the history of the procurement. Actually, when the teams were pursuing and bidding on this project, VDOT made it available or opened up the option to propose either an immersed tube or a bored tunnel. The agency didn't specify or require either one, but really looked to the innovation of the construction partners to bring what worked best for this area, for this region. So we're excited to see that move forward. We have another question about the TBM, is how many people work in the tunnel machine? And do they need specialized capabilities like being underwater experts?
No, well, it's a very small group of mostly highly specialized people that all told at the heading or at the TBM, we're talking maybe 15 people in one single shift. And so it's highly mechanized. Very sophisticated control systems that are pre-programmed, and so you have one TBM operator who lives in a room the size of a small container with all of the panels and systems to control the advance of the TBM in every minute detail. The guidance system, for example, is controlled through him, pre-programmed, but still controlled to make sure we don't deviate. And we're driving these TBMs within less than half an inch of precision in all three axes. And so behind him, you have people that do the erection of the segmental lining. That's a small crew that are fairly specialized. And behind that, you have the mechanics, the electricians, and all that to maintain. So 15 people to drive the tunnel, and behind that, probably another 10 people for maintenance, because there's ongoing maintenance, of course, on this operation.
Certainly. And now as the operators and the tunnel team is doing their work, physically, where are we relative to the existing tunnels? Are we deeper? Are we at the same level relative to the existing?
The new tunnels are approximately 50 feet below the level of the existing immersed tube tunnels, and obviously offset by several hundred feet, but relatively close all in all.
Certainly. We have a question about the launch shaft. We've talked a bit about the TBM and how it does its work, but if we move back to the portal on the island, in fact, the slide that we have up here is looking right at where the TBM is going to start its journey. And there's a question about how physically does the TBM start its dig? We know that it's sitting inside that launch shaft, and does it dig through the concrete walls, and how are those walls reinforced in a way that keeps them strong enough, but still is a way that the TBM can dig through them?
So the walls of the supportive excavation are 4-foot reinforced concrete walls, but at the location of the first tube, or both tubes actually, the reinforcement is made of fiberglass bars that can easily be chewed up by the TBM. However, if you had reinforcing steel, that would be a problem. So we designed it to have fiber reinforced fiberglass bars, I'm sorry, and so the TBM will drive right through that. Before we start the drive on the inside of the shaft, we have to assemble a seal that that the TBM goes through, so that as it punches through the concrete wall and the break-in, breakout plug, which is a conditioned soil on the outside of the shaft of about, I think in this case, 50 to 60 foot in length, the TBM penetrates that and must be sealed so that when it transitions into the in situ ground that of course is under the water table and unstable, we have to pressurize all of that to keep it stable. And so the seal at the shaft contains that pressure until such a time as we put the segmental lining in place, and then grout around that so that we're completely sealed from the in situ condition, which is pressurized, in this case, I think 3 atmospheres, to, atmospheric condition on side of the shaft. So it's a delicate operation that requires a lot of expertise when you launch that machine to make sure that you don't have what's called a blowout into the shaft just of material. I mean, I've done it several times. When it's done properly, there's no issue, but you have to do it properly.
And this will happen both on the South Island and the North Island when the machine starts both shafts?
So that's correct, yes.
Now, you were mentioning the pressure that the TBM was building up as part of its drive. What steps are being taken to protect the marine life from the tunnel digging and boring? Will there be any impact on marine life with this pressurized work going on?
No, because everything is self-contained, and we monitor the pressures in the excavation chamber to make sure that we don't exceed the hydrostatic head that we have and cause any frac out that could impact marine life at the bottom of the seabed. That's extremely unusual. My experience, when you control the machine properly with the ground conditions that we anticipate here, I don't see a problem. So it's self-contained.
Thank you. Now, in order to get all these steps done, it takes a large team. And will local contractors be used for building the project? And if so, have they been selected yet?
We have a very extensive procurement program that's in place that we launched over a year ago, actually. And we already have on board several contractors, local, national, and even, I dare say, international. And it's an ongoing effort. And this effort is particularly geared towards the local contractors, MBE, DBE, SWAM contractors. And so far, we've been very successful in engaging with local community.
Yes, I know that there's a number of outreach events. Pete, can you maybe say a few words to some of that effort?
Outreach events as far as the small business and the DBE.
Yes,
Yes, we have a very, very active program. We have an office in Richmond who specializes in that, the Bowden Center. Plus, actually, the project itself has had several open houses. They've had actually meetings sponsored by the Secretary of Transportation and the Commissioner to talk about this particular project. And HRCP has done a fabulous job of publicizing the project and the opportunities at multiple venues and multiple times. They're really looking to engage the local contracting community.
That's great. We have a few more questions about the TBM, and although I see it's 6:30, we'll go ahead and, as long as the questions are coming, we'll go ahead and address these. How will the machine arrive? Louis mentioned a bit that it would come by ship, but how much assembly will there be to be done, and how will it be offloaded?
Well, from the ship, if it's similar to the ship I've used in the past, these are ships that are equipped with very large cranes, and so the heavy components are loaded onto barges at the port of arrival, and then from the port, the tug will bring it to the island where we'll have a wharf. From at that point, our main crane, which is 800-ton capacity, huge crane, will pick up these large pieces and then transfer them to an assembly pad that is built right next to the shaft, where we will launch the machine. Yeah, right there. And so all the other components that are lighter and the containers are going to be trucked from the port of arrival to the island, as required for the assembly process. Yeah.
Another question about the machine is, will the public have an opportunity to see it or to visit it or see it in action?
No, the straight answer is that with an island of that size, there's really no place to put I guess a visitor's gallery, you might want to call it. It's just too congested with too much activity, so it wouldn't be safe. However, I believe there will be opportunities to see on the various like on the website, newsletters, news on progress of the arrival of the machine, the assembly of the machine. Obviously, once it's underground, there's not a lot to look at. So yeah.
True. And I understand we're working on getting a scale model of the TBM that will be available to the public to look at and understand a little bit more about the different elements you mentioned as part of your presentation and how the machine functions.
That's correct.
One of the questions about further about the TBM is, as it's excavating the soil, there's the cutting tools on front that would wear down depending on the soil. How does one change those? How do we anticipate changing those cutting tools along the drive?
Well, interesting question. This particular machine, because of its dimension, allows us to build, call them chambers, where you can dial the head directly in front. So if you have a tool that's on the head, they're all what we call backloaded, which means that if front load would be, in contact with the soil, back load is inside the chamber, so you're isolated from the ground. You're still at hyperbaric conditions, so it's pressurized in there. But when you dial the machine to these, we've got a chamber, you can actually seal that the cutting tool in that chamber and remove it by hand with that at atmospheric pressure. So we won't have to have hyperbaric interventions, which is what you typically have done. So again, these are more advances in the technology. There's a particular machine that was used in Hong Kong a few years ago at 60-foot diameter that had similar chamber with a robot inside. So there was nobody that would intervene. It was all done automatically with a robot. And so these are all the advances. So this particular machine, we anticipate very few hyperbaric interventions. We are prepared for them, of course. We have everything that's required. We'll have the trained teams that are specialized in hyperbaric intervention, but that would be, in this machine, very unusual if we had to do that. So it's a very safe way of doing it now.
And as the cutter tools excavate the soil, you touched a moment ago on what do you do with all the soil that's being dug up?
Well, as it's cut, it falls into the chamber. So the chamber is full of a material of soil, and this soil is mixed with a bentonitic slurry to increase its density. And that density, that dense soil, if you will, is used to pressurize the face at the same time to stabilize it so it doesn't unravel uncontrollably. So we have a stable front, and then we pump it out at the rate that is required to advance the machine, but we can control it so that we always have a stable front. We monitor the volumes of soil that come in to make sure that it's very precisely the volume we're supposed to excavate. If we see that we're excavating 5%, 10% more, it means we're over excavating, which means we're taking too much soil, which could eventually cause settlements. So we control that very precisely. We have redundant systems to control that. And then as it's removed from the cutting chamber, it's pumped to the surface in a 22-inch steel pipe with a number of, we'll end up probably having 3 booster pumps because of the length here of conveyance of the material up to the shaft into a treatment plant that's on the island where we separate the soil from the water, and then we process that soil to be barged out or trucked out to the landfill.
Thank you. And again, we mentioned the pressurized operation, and that varies along the path of the tunnel. As we get deeper, the pressure increases. What's the maximum pressure that the tunnel, that the seal will have to be held at?
I believe here it's just less than 4 atmosphere, 4 bars. So that's equivalent to about 140 feet of water for those that scuba dive.
Thank you. Well, we just have 1 or 2 more questions to wrap this up. And one question that affects not only those looking forward to the new tunnel, but also using the present day tunnels while the construction is underway is, will the existing tunnels be shut down at any point during the project?
No, that we have a complicated switching operation towards the end of the project when the bridges are ready, when the tunnels are ready, and then we have to make switch some traffic. So it's going to be an interesting sequence of events to make sure that we maintain traffic.
Well, we look forward to doing that over the coming years as the machine is doing its job deep underground, out of sight. But look forward to having those 8 lanes of traffic opened up here in 2025. So with that, that's the questions we have. And we want to thank everyone for attending the virtual open house we've had tonight. We really appreciate everyone's interest in the project, the wide range of questions that we've received, and we do see a couple additional questions coming in, so we'll be able to post some of these as FAQs on our website. We have some frequently asked questions now, but we'll be able to expand that collection based on some of the items that have been highlighted here tonight. And we would encourage everyone to keeping up with the latest on the project progress, continue consulting our website at hrbtexpansion.org, where we have updates, traffic alerts. There's an opportunity on that website to sign up for the monthly project update newsletter if you're not already on that mailing list, again at hrbtexpansion.org. So we thank everyone for their interest, for their participation tonight, and wish you all a good night.